Hi, how are you all? Welcome to today's chemistry class. In the last video, we have discussed about a quantum mechanical model of atom. According to quantum mechanical model of atom, we have studied that atom is just like a sphere and the electrons can be seen anywhere around the nucleus, and that region around the nucleus where there is maximum probability of finding an electron can be called as an atomic orbital. And inside an atom there will be many atomic orbitals, and these atomic orbitals are present in different energy levels, and the electrons are present inside these atomic orbitals. Okay, when we are speaking about a particular electron, in order to identify in which atomic orbital that electron is present, in which energy level that orbital is present, and it is how much distance away from the nucleus, to identify all these things we should know a set of numbers, and these numbers are known as quantum numbers. That I already told in that last video, isn't it? So quantum numbers may be defined as a set of numbers which will give all information about an electron, that is its energy, its location, and the orbital, the shape of the orbital in which it resides. All these things we can know if we know these quantum numbers. Okay, and there are total 4 quantum numbers. The first one is known as principal quantum number, second one is known as azimuthal quantum number, then magnetic quantum number, and the last one is spin quantum number. Okay, so we can study about these 4 quantum numbers in detail. Okay.
Quantum numbers. We know that an atom contains large number of orbitals. These orbitals are distinguished from each other on the basis of their size, shape, and orientation in space. These things or these characteristics of an orbital are expressed in terms of numbers. These numbers are known as quantum numbers. The quantum numbers may be defined as a set of 4 numbers with the help of which we can get complete information about all electrons in an atom. That is, their location, their energy, the type of orbital in which they are occupying, shape, and orientation of that orbitals. So all these things we can identify from quantum numbers. Okay. And there are 4 types of quantum numbers. First one is known as principal quantum number. It is represented by the letter n. And this n can have values 1, 2, 3, etc. These values of n determines the energy level in which that electron belongs. For example, if n is equal to 1, we can tell that electron belongs to the first energy level. Then if n is equal to 2, that electron belongs to the second energy level. If n is equal to 3, that electron belongs to the third energy level. Like that it goes. And these energy levels correspond to the shells in Bohr's atomic model. So the principal quantum number n gives the shell or energy level in which that electron belongs. And its value also determines the distance of that electron from the nucleus. As the value of n increases, the distance of that electron from the nucleus also increases. The second quantum number is known as azimuthal quantum number or angular momentum quantum number. We know that each main energy level or each shell is divided into sub-energy levels or subshells. The number of subshells present in each main energy level or main shells is given by azimuthal quantum number. So azimuthal quantum number gives how many subshells are present in each shells and what are the shapes of these subshells. That also determined by this azimuthal quantum number, and it is denoted by the letter L. And its value depending upon the value of n, that is principal quantum number. The value of azimuthal quantum number is depending upon the value of principal quantum number n. And for a given value of n, this azimuthal quantum number can have value from 0 to n minus 1. For example, for the first shell, we know that n is equal to 1. First shell means K shell. For that, the principal quantum number n is equal to 1. And if n is equal to 1, L can have values from 0 to n minus 1. Here n is equal to 1 means 0 to 1 minus 1. That is 0 only. So for the first shell, we are getting only one value, that is 0. Okay. So for the first shell, the value of azimuthal quantum number is 0. Then for the second shell, that is n is equal to 2, which represents L shell. L is equal to 0. L can have values from 0 to n minus 1. That means 0 to 2 minus 1. 2 minus 1 is 1. So L can have values from 0 and 1. So for the second shell, L can have two values, that is 0 and 1. Like that for the third shell, that is for M shell. L can have values from 0 to 3 minus 1, that is 0, 1, 2. There are three values for L. Okay. Now each value of L that represents a subshell. For example, if the value of L is equal to 0, that represents one subshell, and that is known as S subshell. If L is equal to 0, that represents S subshell. And if L is equal to 1, that represents another subshell, that is P subshell. And if L is equal to 2, that represents D subshell. And if L is equal to 3, that represents another subshell, that is known as F subshell. For the first shell, that is n is equal to 1, L has only one value, that is 0. So we can tell that the first shell has only one subshell because L has only one value. And that value is equal to 0, that means S subshell. If L is equal to 0, that means S subshell. So we can tell that in the first shell or in the first energy level, only one subshell is there, that is S subshell. And that can be represented as 1s. Like that for the second shell, L has two values, that is 0 and 1. That means second shell has two subshells. And if L is equal to 0, that means S subshell, and L is equal to 1, that means P subshell. So for the second shell, there are two subshells, S subshell and P subshell. And they can be represented as 2S and 2P. Like that in the third shell, L can have three values. So depending upon that, there are three different subshells. And they can be represented as 3S, 3P, 3D. Then in the fourth shell, L has four values. So depending upon that, we are having four subshells. L is equal to 0 means S subshell, L is equal to 1 means P subshell, L is equal to 2 means D subshell, and L is equal to 3 means F subshell. Okay, and these subshells can be represented as 4S, 4P, 4D and 4F. Okay. This figure shows the representation of different subshells present in each energy level or each main shells. Okay. So here n is equal to 1 means it contains only one shell, that is one subshell, that is S subshell, that can be represented as 1s. Then second energy level, n is equal to 2 means it contains two subshells, S subshell and P subshell. Then in the third energy level, three subshells are there, SPD. In the fourth energy level, four subshells are there, that is SPDF. Okay, so this is a representation of different subshells present in each energy level. Okay. Now, the third quantum number is known as magnetic quantum number. This magnetic quantum number determines the number of orbitals present in any subshell. Already we have studied that in an atom, according to quantum mechanical model of atom, this atom contains energy levels. Different energy levels are there. These energy levels are known as shells. And these shells are divided into subshells. That already we have seen. Then these subshells are again divided into orbitals. So how many orbitals are present in each subshell? That is given by magnetic quantum number. Okay, and this magnetic quantum number is denoted by the letter ML. That L should be subscript. Okay, and the value of magnetic quantum number is depending upon the value of azimuthal quantum number L. For a particular value of L, M can have values from minus L to plus L including 0. For example, if L is equal to 0, ML can have value from minus L to plus L. That means minus 0 to plus 0. That means 0 only. Okay. So for L is equal to 0, that magnetic quantum number has only one value, that is 0. It means that L is equal to 0 means S subshell, isn't it? So for S subshell, magnetic quantum number has only one value. That means S subshell has only one orbital. That is known as S orbital. Okay. Then for L is equal to 1, that represents P subshell, and the possible values of ML are minus 1, 0 and plus 1. That means 3 different values are there. So P subshell contains 3 orbitals. For L is equal to 1, that represents P subshell, and for L is equal to 1, this magnetic quantum number has 3 values. As a result, P subshell contains 3 different orbitals. And these 3 different p orbital can be represented as px, py, pz. Okay. Now, for L is equal to 2. L is equal to 2 means d subshell. And if L is equal to 2, this magnetic quantum number has values from minus L to plus L. That means minus 2 to plus 2 including 0. So which are the values? Plus minus 2, minus 1, 0, plus 1, plus 2. 5 different values are there. That means d subshell contains 5 different orbitals. Okay. D subshell has 5 different orbitals. They are dxy, dyz, dxz, dx square y square and dz square. These are the 5 different d orbitals. Like that, if L is equal to 3, that represents F subshell. And for that, the possible values of magnetic quantum number are minus L to plus L. That means minus 3 to plus 3 including 0. So minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. These are the possible values of magnetic quantum number. Total 7 values are there. So we can tell that for F subshell, there are 7 different orbitals. Okay. Like that it goes. So this table shows how many orbitals are possible for each subshell. For a subshell, we are having only one value for M. That means only one type of orbital is there. For P subshell, there are 3 values for magnetic quantum number. That means 3 different orbitals are there. Then for D subshell, 5 values are there for magnetic quantum number. That means 5 different d orbitals are there. Then for F subshell, 7 values are there for magnetic quantum number. That means 7 orbitals are there. Okay. Now the last quantum number is known as spin quantum number. And this spin quantum number is denoted by the letter ms. That ms should be subscript. And this spin quantum number gives the information about the direction of spinning of electrons around the nucleus. Already we have studied that electrons are revolving around the nucleus, isn't it? So when these electrons are revolving around the nucleus, they are spinning in their own axis. Just like planets are revolving around the sun, while revolving around the sun, they are rotating in their own axis, isn't it? So like that, these electrons, they are revolving around the nucleus, at the same time they are spinning in their own axis. So this spinning of electron is possible in 2 ways. That is, they can spin either in the clockwise direction or in the anti-clockwise direction. So depending upon that, we are having 2 values. Due to the spinning of electrons, it is getting 2 values, that is plus half or minus half. So these are the two possible values of spin quantum number, plus half or minus half. If the electron is spinning in the clockwise direction, it will have plus half, and if it is spinning in the anti-clockwise direction, it will have minus half. Okay, so the spin quantum number has only two values, either plus half or minus half, which arises due to the spinning of electrons either in clockwise direction or in anti-clockwise direction. Okay. Now, consider for an electron, the principal quantum number n is equal to 3 and the azimuthal quantum number L is equal to 1. So, can you tell in which orbital that electron is present, or in which subshell that electron is present? N is equal to 3 means it is that electron is present in the third shell. The principal quantum number n determines the shell in which that electron is present, isn't it? So n is equal to 3 means that electron is present in the third shell. Then L is equal to 1 means which subshell? L is equal to 0, S subshell. L is equal to 1, P subshell. So here that electron is present in the P subshell. That means that electron is present in the P subshell, which is present in the third shell or third energy level. So that can be represented as 3p. So we can tell that this particular electron is present in the 3p orbital. Clear? So this is about quantum numbers. I think it is clear for all of you.